So these distributed property examples are going to be the most important ones for us. So it's pretty easy if you just have one expression. But when you have two expressions like this, you want to make sure 2 times v minus 1 goes together. And then you're going to multiply the other side, 7 times v plus 3, right? And we know we have to distribute. So 2 times v is 2v, and 2 times negative 1 is minus 2. And then 7 times v, 7v. And 7 times positive 3 is positive 21. Everybody good with that distributive property? Questions on that? It's just a detail that some students forget to do. And then I always subtract my smaller variable. So 7 minus 2v is going to be 5v. And then 21, subtract that over to the other side. And we get 23 negatives, right? And then we divide, and then v equals negative 23 over 5. Kind of a weird fraction. Okay. All right. So that's kind of our foundation for what we're going to do today. We're talking about things that are similar today. So up until now, everything's been exactly the same size, exactly the same shape. You could lay it on top of each other like sticky notes, and they're just going to stack right on top of each other, right? They don't have to be stacked. They can be separate, but you can always restack them if they're congruent. If they're similar, one thing is going to be big and the other thing is going to be small, okay? They're going to have some relationships, but they're going to be different sizes. So one thing is small and one thing is big. Same shape, but different size. The angles are always going to be congruent, okay? So if you want to change this color, do something, the angles are always going to be congruent, but the sides are going to be proportional. That means we're going to have to make a proportion to solve when we're talking about sides, okay? So angles are always congruent and sides are always proportional. So what does that mean? I'm going to zoom in a little bit here. There we go. So we can look at our key, right? Notice that this symbol in the middle is different. If you have this symbol right here, you need to automatically think proportion, okay? If you have that similar symbol is just the squiggle with no equals under it. That means all your angles are going to be the same. Angle J and angle P are going to be congruent. Angle J and angle P are going to be congruent. And angle K and angle M are going to be congruent. K and M, right? They're going to be exactly the same. And angle L and angle N. Angle L and angle N are going to be exactly the same. However, these sides, the yellow side, the green side, and the blue side, they're going to be proportional. So you're going to have to make a fraction and set it equal to another fraction. So I can do this set of fractions, or I can do this set of fractions, okay? Because in a proportion, I can only relate 2 fractions with each other. All right? So let's see what that looks like over on the other side. I know all my angles are the same. So angle A equals angle D, angle B equals angle E, and angle C equals angle F. Those are easy. Angles are always super easy. Do those first. Sides, however, are a little bit different. So if you take the X and the 28, that's the small triangle, right? So this small triangle, I'm going to put those 2 sides that I know next to each other in my proportion. X next to 28. They're in the same small triangle. That's why it says S right there. So they have to go together. Then I take this big triangle. The yellow side has to go with the yellow side. So because AB goes with DE, AB has to go with DE. These have to go next to each other because they match. They correspond up here in my key. And then the 20 and the 28 go together because they also correspond over here, DE and BC. Okay, so you're going to probably want to color code these a little bit. Once you have the proportions set up, it's easy to solve. X times 20 is 20x, 25 times 28 is 700, divide by 200 and you get 35. Always think, does that make sense? Put your answer back into your picture and make sure it makes sense. I've got 2 small numbers and 2 big numbers. That kind of makes sense. My big number is what was missing, and my big number is what I got. Okay? If you're given a scale factor, that just means that you're going to multiply everything by that scale factor. Okay? So you're going to put the scale factor. In this case, it's 2, 3. I always put my small numbers over my big numbers, and this will make sense when we start to do practice. So the 2 goes on top and the 3 goes on the bottom. Because this is the small shape, the 42 has to go next to the 2. 42 and 2 are the small things. 42 is in the small shape. I'm predicting I'm going to get a bigger number. So now you cross multiply 2 times x and 3 times 42 and divide by 2 and we get 63. If I put that number back into my drawing, that makes sense. 63 is bigger than 42 and it should be. Okay? All right, let's look at the next slide and just make sure we're good. Proving triangles similar. There's 3 ways to prove that they're similar. Remember that the similar symbol is just the squiggle with no equal sign under it. Okay? We can do angle, angle, where we've just got 2 angles. Like I said, this is the easiest one. Okay? I've got those vertical angles, and I've got one other set of angles. If you have 2 sets of congruent angles, you are done. Right? I'm not given any sides at all. I just have 2 sets of angles, angle, angle. If we've got 3 sets of sides, this is the hardest one, I think, just because it's the most work. We need to identify what the sides are. So I've got a small side and a small side. They go together. I've got a medium side and a medium side. They go together. And then I've got a large side and a large side, and they go together. In this case, because I have all 6 numbers, all I have to do is reduce them. 3 over 6 reduces to 1/2, 4 over 8 reduces to 1/2, and 5 over 10 reduces to 1/2. Because all of these are the same, then my shapes are similar. Because I've got to have proportions. Okay? So when you have 3 sets of sides, figure out what the small sides are, reduce them. Figure out what the medium sides are, reduce them, and the large sides and reduce them. If they all reduce to the same number, then you have similar triangles. If they're not equal, then they're not similar. Okay? And hopefully this will make sense as we practice. So we've got angle, angle, we've got side, 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 right? This is the easiest one. This is the hardest one, I think. And then side, angle, side. This is our combination one. You have to have an angle that's connecting 2 pairs of sides. If you don't have that, then you've got nothing, okay? So you can always sort these into whatever they could be and then decide whether it's true or not. So if I've got 2 sets of sides, I've got an 8 and a 6. So I've got 8 and 6. And I've got 20 and 15, 20 and 15. Divide them or reduce those fractions, just like slope. 8 divided by 2 is 4, 6 divided by 2 is 3, 4/3 and 4/3. So our sides are proportional. And we've got these angles here that are congruent. So I've got side, angle, side, and side, angle, side. Okay? I just gave you a whole bunch of information. What I want you to do is over here on the right side, write a quick little summary about what you've learned. Include anything that you think is important to remember and also anything that is confusing. Describe how the shortcuts for triangle similarity compare to the triangle shortcuts for triangle congruence, right? So what are the 3 ways for triangle similarity and what are the 3 ways for triangle congruence? Put that in this box right here. Just a little cheat sheet for yourself. So what I want you to do is write down the 3 ways you can prove congruent, or 3 ways you can prove similar, 3 ways you can prove congruent in that yellow box. Give yourself some notes so you know which one is which. So we've got congruent, and we've got similar. Both of them have side, side, side. Both of them have side, angle, side. For similar, you can do angle, angle. That's different. And for congruent, you can do angle, side, angle, 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 side, or hypotenuse, leg. Did I already do it for you? All right. Any questions? Should we practice them? It never makes sense until you practice. Okay. I'm going to put another Pear Deck link in the chat. If you would rather have the Google link, please go to our today's folder, 415, if it's not already open, and into our page. We're going to do these 5 questions together. Hopefully this will make sense. All right, there's the link in the chat to the Pear Deck that I'm opening now. If you're already in Schoology, you can open it yourself. So because they're similar, right? I know I have one small shape and one larger shape. What do I know about the angles? They are congruent. So what does angle F go with? And angle, so angle F goes with angle J, and then angle G goes with what? So angle G and angle K, and then angle H and angle H, right? Our sides, however, what sides go with what? What does GF go with? What does GF go with over on the other triangle? KJ. So GF and KJ can go in a fraction together. Oh, I need another color. What about GH? What does GH go with? KH. And then our last one, let's do orange, is going to be FH. FH. Oops, that's an H. And JH. JH. That's a J. So F goes with J. F goes with J. Say it again. It's angle mark. I'm glad you asked. So what I want you to notice here is that the GHF triangle is all on the top. GHF, all of those triangle pieces are the small triangle, so they have to go all together. okay? And then I'm running out of colors. All of these bottom parts of our proportions are all from the same triangle, HKJ. All my HKs and Js are the large triangle, so they have to all go side by side. I personally always put small on the top and large on the bottom. It takes away a decision that I don't have to make every time because I always know small goes on top and large goes on the bottom. You can 100% flip that upside down as long as you're consistent. So all of your smalls have to be next door neighbors and all of your larges have to be next door neighbors. Okay, does that make sense when I say that? All of these small sides have to go next to each other and all of the large sides have to go next to each other. Okay, let's go to the next slide. Oh. There's only 5 of them, and I want to give you guys time to practice on your own too. Can we go to the next one? Okay. So now we're looking for x, right? So this is going to be how we solve. I've got this triangle over here. Visually, this looks like my large triangle, right? And I've got a small side and a large side of that triangle. So in my large triangle, I'm going to put those numbers on the bottom of my proportion, 32 and 36. This is my small fraction. These are my small numbers. This is my big numbers. This is my big fraction, right? So then over here, I don't know which one is small and which one is large. So I got to look at my key. AG goes with KX. So AG goes with KX. Those two things have to go together. You with me? Samuel, you all right over there? GM goes with XD. So GM goes with XD, X plus 6. So in my decision making, I started with the triangle that had numbers in it because it's always easier to start with numbers than expressions. And I did 32 next to 36, 32 next to 36. Then I said, okay, what does the 32 go with? AG goes with KX, so 32 has to be in a fraction with X plus 3. Then GM must go with the X plus 6. Now, all we've got to do is cross multiply, right? I say that a little cavalierly. These are kind of big numbers. They're not going to be the easiest things on the planet to do, but I have confidence we can. This is where the proportions from yesterday come in. So what's the next step? What do I have to do here? Distribute, absolutely. So 32 times x, 32x. Don't forget to do 32 times 6, right? I'm reaching for my calculator because I'm not going to do that in my head. 32 times 6, 192. 192. Then I've got to distribute here, 36 times x and 36 times 3. So 36x plus, probably could do that if I really was willing to expend the energy. 108. And then we subtract. 32 from 36 is 4. And 192 minus 10, that's an 8. 192 minus 108 is 84. And then we divide, and x equals, did anybody get that yet? Awesome. Okay. We could kick this up a notch and say, what's the length of XD? If I said, what's the length of XD, we would do 21 plus 6, which is 27. And we would do 21 plus 3, which is 24. Okay. You can always check that for reasonableness. 32 is smaller than 36 and 24 is smaller than 27. So it makes sense what we got. Some students get this right off the bat and some are like, oh my God, that's a lot of working parts. How are we feeling? Pretty good, I like it. All right, let's see what number 3 has to hold for us. How do I set this one up? Awesome. So what does the 25 go with? What's TL go with? And then that must mean that x plus 5 goes with this one. So when I go to solve this, what do I get when I do my proportion? Does it matter which diagonal I do first? It doesn't. So 10 times 4x minus 1 equals 25 times x plus 5. And what do I get when I do this math? And then 25x and and then we subtract. What do we subtract first? Absolutely. So what do you want to move first? Okay, so if I add 10 to both sides, I get 135 over here. And get 15x. So what does x equal? Awesome. And that is what I'm being asked for, so this is my answer. Always double check to see if that's really what's being asked, okay? Geometry is super tricky in that way. All right, this one's a little different. What do I do now? How do I use that scale factor? Think it through with all the same stuff. What do you know? Which one is bigger, 6 or 5? 6. So I can either do 5 and 6, small over big, or I can do 5 and 6, small and big. Do we want to do 5, 6, choice 1, or 5, 6, choice 2? Do we want to put them on top of each other or next to each other? Okay. So if we do 5 and 6 next to each other, right? And I always do the small one first. You don't have to do it that way, but that's how I do it. Then if this is the small number, which this one has to be the small number because that's visually the smaller shape, right? So the 28 has to go with the 5. And then the 6 is the bigger number, so it has to go with this big side, which is x. The other way to do it, or another way to do it, because there are literally lots of ways to do this, if we had decided to do 5 and 6 top and bottom, then still the 28 has to go with the 5, and the x has to go with the 6, because this is small and this is big. The magic that happens is when you cross multiply. It's still going to be 5 times x, or 5 times x. and it's still going to be 28 times 6 or 28 times 6. So the crazy thing with proportions is 4 of us could write a different proportion with the same 4 numbers and get the same right answer. That makes people crazy sometimes, okay? We can do a lot of correct methods in order to get the right answer here. What is 28 times 6? Probably. Yep. So what is 128 divided by 5? 25 point. Say it again, Miriam. 33.6. 33.6. So if I put in my 33.6, I'm glad the decimal gives you pause, but it can be a decimal. It's probably going to be a decimal because 5 doesn't go into 28 evenly. And that makes sense. My small triangle is 28. My bigger triangle is 33.6. Every time you do a proportion problem, I want you to go back and ask yourself, does that make sense? If you put in that number and it's supposed to be a bigger number, is it a bigger number? If it's not a bigger number, then you've done something crazy. Okay. Last question we'll do together, and then I'm going to let you go on your own. They're not always going to be triangles. Sometimes they'll be different shapes, but the method is exactly the same. Oop, I don't want a highlighter. So if you know 32 and 40, and you know X and 75, how would you set that up? I know my similar symbol is going to make me do a proportion. So what numbers do you put in first? I know. Miriam's like carrying the class today. What numbers would you start with? There's no right or wrong answer here. You just have to make a decision. The small ones, I hear somebody, or I see somebody say. So if I start with a small triangle, let's do 32 and 40. Once we make that decision, now what comes next has to be true. So YZ goes with what? YZ goes with RS, X, absolutely. So the 32 and the X have to go together. The 32 and the 40 can go in a lot of different places. This is where I choose to put them almost every time. But the 32 and the X have to go together, which means then the 40 and the 75 have to go together. Okay. And then you just cross multiply. So 40x equals whatever 75 times 32 is. 2,400. And then x equals 60, question mark? Sweet. And again, it's saying find the value of x, so we know we're done. If I put my 60 in here, that makes sense because the 40 and the 75 are bigger than the 32 and the 60. Okay? You're right. I just did this backwards of what I've been telling you to do, didn't I? I put the large on the top and the small on the bottom. So if we do it the other way, it'll still work out the same. 32 over x and 40 over 75. This is the small on the top and the large on the bottom. It's still going to be 32 times 75 and x times 40. I'm glad you noticed that. Thank you. Okay. All right, now it's time for you guys to try. In the next slides, I'm going to put another Pear Deck. I know you guys are like, oh my God, can we stop with the Pear Decks? But this is the best way for me to be able to watch what you're doing. I know, it is insane that it still works, isn't it? Somebody's like, wait, but I want a single procedure that works every time. Uh-oh. That link's not going to work. Let me open a new link for you. That must be the one from last term. So in this set, once you get it open, what I want you to do is eliminate all of the choices that it can't be. So like in the one that I'm showing you right now, what are you given over on the left-hand side? Sides or angles? Well, give me a minute. All right. Try that second link. I think that's going to be a better link for us. Does that link work in the chat? So I am going to look at this. This will likely be a grade. So everybody needs to find this link. And I can change it in here too if you're going through Schoology. 1, 2, 3. All right. So what I want you to do here is I'm given sides, side, 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 right? It can't be angle, angle. I'm not given 2 angles. It can't be side, angle, side because I don't have any angles. The only thing this can possibly be is side, 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 or not. So what I want you to do is put these in order: small, medium, large, small, medium, large, and then match them up: small, medium, and large. So 12.5, 15, and 20. In the notes, we reduced these, right, to smaller fractions. These 2 fractions over here are easy to reduce. This one with the decimal is a little bit harder. So what I want you to do here is actually find the decimal. Do 5 divided by 12.5 in a calculator. And then do 6 divided by 15 in a calculator. And 8 divided by 20 in a calculator and get a decimal. What do you get for each of those decimals? 5 divided by 12.5, 6 divided by 15, and 8 divided by 20. What decimal do you get? Yeah, 0.4. 0.4 for every single one of them. If they match, this is side, side, side. Okay, all we did was find the decimal. We divided 5 divided by 12.5, 6 divided by 15, and 8 divided by 20. We did the 2 small sides together, the 2 medium sides together, and the 2 large sides together, and then just found the decimal. If they all match, and they have to match exactly, they can't be super close, then you've got side, side, side. If they didn't match, then you would say they're not similar. Okay. I'm going to stop sharing. I want you guys to go through these. I'm going to watch you on Pear Deck. Make sure you eliminate the choices that don't work because you don't even have that information. You can't Did you try the second link? Yeah. Did that one work? No, I'm glad you let me know. So remember in number 2, you can mark those vertical angles. So you can always mark the vertical angles. And then you've got 2 sets of sides. So it can't be angle, angle. You don't have 2 sets of angles. You only have 1. It can't be side, side, side because you don't have 3 sets of sides. You only have 2. So it's got to be side, angle, side, or not. So you know you've got the angle. With the sides, if you do 16 divided by 39 and 16 divided by 40, do they give you the same decimal? If they give you the same decimal, then it's a yes. If they don't give you the same decimal, it's a no. You definitely have to check it though. They have to be exactly the same. They can't be close. So again, in slide 2, 16 over 39 has to equal 16 over 40. If it's going to be side, side, side. If that doesn't work, then it's got to be side, it's got to be not.